Hello all. Today we will learn about spanning tree protocol, which is also commonly called as STP. But before we move on to the details of spanning tree protocol, I would like to get into a bit of detail about what a MAC address table is, how a MAC address table is populated in a layer 2 switch, what is a loop in layer 2, and how is it different from a layer 3 loop, and how spanning tree protocol solves these layer 2 loops. So MAC address table, as we know, the layer 2 switches or layer 2 devices, they talk to each other, or they talk or forward any traffic from source to end based on a MAC address table. In our previous videos, I had explained about the layer 2 headers and how a MAC address is important in forwarding a layer 2 packet even inside a layer 2 network and with a ping as well. So how is a MAC address table populated with different types of traffic? This is what we are going to understand today. Okay, so let us understand first what are the contents in a MAC address table. So these contents may vary or may vary based on the platform. Contents here meaning the output that is displayed in a MAC address table may vary based on the type of platform. A MAC address table in a Cisco device may vary from that of a Juniper, Calyx, Sienna, etc. So in general, what is inside a MAC address table? So in a Cisco device, when you do a MAC address table or show MAC address table, you would usually see entries like MAC address, then you would see a VLAN number and usually port or an interface number. So what are populated inside these fields? So in a MAC field, the destination MAC is usually populated. So you will contain the destination MAC address here. VLAN, if that destination MAC is a part of a particular VLAN, that would be populated in the VLAN field. Let's say that particular destination MAC address is a part of VLAN 10. So a VLAN is populated, and via which particular port or interface can this destination MAC be reached, or the traffic may be forwarded out of that particular port or interface. Number or ID is usually populated here. For example, fast Ethernet 1/0. So let us imagine that a particular switch has received an Ethernet frame whose source MAC address is all A. It is a part of VLAN 10 and it was received on fast Ethernet 1/0. So when a switch sees its MAC address table, it knows that any Ethernet frame whose destination MAC address is all A and is a part of VLAN 10 can be forwarded out of port fast Ethernet 1/0. Now, please understand that a switch usually learns MAC address when it receives an Ethernet frame on an receiving interface. Let us understand this with a simple diagram. So we have two switches, switch 1 and switch 2 respectively, and their MAC addresses are all B and all A, for example. So let's say that when when switch 1 receives an Ethernet frame from switch 2, Let's say that this is interface 1 and interface 2. So if you remember from a layer 2 header perspective, when switch 2 sends a packet to switch 1, it has a source MAC address field. In that particular source MAC address field, it will populate all B's as its source MAC address field. Now, when A or switch 1 receives this Ethernet frame, how will it populate this? Let us consider that we do not have any VLANs here. So, how will switch 1 populate this particular Ethernet frame that has been received by switch 2? So, what it does is when it receives the packet from switch 2, it sees that the source MAC address is all B. So please understand, a switch populates the MAC address table by looking into the source MAC address field. So the source MAC, when it received an Ethernet frame from switch 2, is all B. So it populates all B in the MAC address field. And on which port was it received on? It was received on port number 1. So this is how the MAC address table on switch 1 would look like. If it has to send an Ethernet frame to switch 2 or any Ethernet frame whose destination MAC address is all B's, it will forward it out of port 1. Similarly, for switch 2, when it receives an Ethernet frame from switch 1, how will it look like? So the MAC address of switch 1 is all A. So when switch 2 receives it, it sees the source MAC address field and it populates it in the MAC address column, and it populates it as all A. And it received that particular Ethernet frame on interface 2. So it populates 2 under its interface column. So switch 2 knows that if it has to forward an Ethernet frame with the destination MAC of all A, it will forward it out of port 2. All right. Now, let us understand the different types of traffic in a layer 2 network and how these traffics are usually processed by a switch. So there are three different types of traffic in a layer 2 network, which are a broadcast network, a unicast network, and an unknown unicast. I'm sorry for calling them as network, but broadcast traffic, unicast traffic, and an unknown unicast traffic. What are these? So a broadcast traffic in a layer 2 network will have a destination address of all F's, right? So broadcast meaning that it will be sent out of every transmitting interface except the interface that this particular broadcast traffic was received on. So broadcast meaning it will be sent out across all the interface to all the switches or devices in the layer 2 network. That is all F's. It may have the source MAC address as something. Let's say that the source MAC address is all B, but the destination MAC is all F's. So it's a broadcast packet. What is a unicast traffic? Unicast traffic means that it has a source MAC address. It also has a destination MAC address. So it originated from a device whose MAC address is all A, and it is intended to go to a device whose MAC address is all B. It is a unicast traffic. Now, what is an unknown unicast? Now, let's say that, imagine that this is a switch 1, and it has a MAC address table. Let us imagine that the MAC address table of switch 1 already has two MAC addresses in it. Let's say that these MAC addresses are all A's, all B's, and all C's. And they were received on the interfaces 1, 2, and 3, for example. Now, let us understand how an unknown unicast will play role in an already populated MAC address table. So let us imagine that this switch 1 received an Ethernet frame whose source MAC address is all D and whose destination MAC address is all E. So, as I had mentioned earlier, a switch learns or populates its MAC address based on the source MAC address. So, let's say that this particular Ethernet frame was received on interface number 4. So it sees that I received an Ethernet frame on interface number 4 whose source MAC address is all D. But I do not have the destination MAC address. I do not have a destination MAC address of all E in my MAC address table. Where will I forward it? How will I forward it? Because I do not have any information for it. So what does it do? A switch or a layer 2 device will always treat an unknown unicast as a broadcast frame. So, what will it do? It will forward this particular unknown unicast frame out of its all the interfaces except the interface that it received on. So except the interface 4, it will forward this particular unknown unicast frame through port number 1, 2, and 3. All right. So this is how a layer 2 device treats these three different types of traffic. Now moving on, let us understand with these three different types of traffic how a loop can be formed. Now, before moving on to a loop, we have two different types of loops, one for layer 2 and one for layer 3. If you remember from my previous videos where I had explained the layer 3 header, we had a field in layer 3 header called as TTL, time to live. What is the work of a TTL? In a layer 3 network, if a packet is revolving around in a network, it is getting circulated in the network infinite amount of time. That is a loop. But in layer 3 header, we have a field called TTL, time to live, which does not allow this. By default in Cisco devices, the TTL value is 255. And as the packet travels from one hop to the other hop or one router to another router, this TTL value is decremented by 1. So the moment the packet is circulating in the network, this TTL value is decremented, and the moment it reaches 0, that particular packet is dropped and it is never seen in the network ever again. But in a layer 2 header, we do not have a field called TTL. We do not have a field called TTL. So how is a loop prevented in a layer 2 network? But before we move on to how it is prevented, let us understand how a loop is formed in a layer 2 header or a layer 2 network. So, loop in layer 2. So, while understanding this, please have in mind about the three types of traffic and how a MAC address is usually populated in this switch or a layer 2 device. So, let us take an example of three switches and three PCs who are new in the network and who are unaware of each other's existence. So here I have drawn three switches connected to three edge devices or PCs, namely A, B, and C. I have also marked their interfaces, namely 1, 2, and 3 in each switches. So let us imagine that the MAC address of PCA is all A, PCB is all B, PCC is all C, right? Now, let us say that PCA sends an Ethernet frame to PCB, all right? So, the source MAC address in that particular layer 2 header, what will be? The source MAC would be all A, the destination MAC would be all B. Now, here let us imagine that the MAC address table of all these switches are empty. So I have marked all these MAC address table empty. So now A sends a packet. This packet is received by switch 1. This packet is received by switch 1 on port number 3. So it populates the table as port number 3 and it reads the MAC address, the source MAC address, and it populates it as all A, meaning that if I have to reach a destination MAC of all A, I can reach it via my port number 3. Now, since the MAC address table of switch 1 is completely new, the destination MAC of all B is not populated. As I had mentioned earlier, an unknown unicast traffic is treated as a broadcast traffic by a layer 2 device. So a broadcast traffic is forwarded out of all the interfaces except the interface it was received on. So switch 1 forwards this traffic out of port 2 and out of port 1. So let's imagine that this particular Ethernet frame is received by switch 3. So on switch 3, it sees that I have received an Ethernet frame whose source MAC is all A, and I received it on port number 1. Since this is an unknown unicast for it as well, it will forward it out port number 3 and port number 2, right? C will, of course, receive this packet. C, that is the PCC, will of course receive it. But however, it sees the destination MAC. The destination MAC is all B. The source MAC or the MAC address of PCC is all C. It will discard this packet. Now, let us see what happens when switch 3 forwards this packet to switch 2. Switch 2 will receive this on port number 1. It sees that the source MAC is mentioned as all A, right? Now, again, switch 2 sees this as a unicast Ethernet frame, an unknown unicast Ethernet frame, and it forwards this particular frame out of port number 2 and port number 3. Now, Here is where the loop formation is going to happen. Switch 1 would receive this packet from switch 2. It again sees that it has received a packet or an unknown unicast frame on port number 2 whose source MAC is all A. Now, whenever a new information is received by a layer 2 device, it usually overwrites the old MAC address. So it received a new Ethernet frame whose source MAC is A, but it was received on port number 2. What it does, it cancels this out. All right. So this packet is updated in the switch one's MAC address table. Now, let us imagine the other way, right? Let us imagine if switch 3 receives this packet on its port number 2, meaning that in the first round, when switch 1 forwarded the unknown unicast via port 2, it was received on switch 2 and then it was forwarded to switch 3, right? So now what will happen? Switch 3 also receives this. Switch 3 sees that I have received a source MAC of all A, but it was received on my port number 2, right? Now, what would happen? This packet is actually being circulated, right? This is just one part. Now, what would happen if all these packets or all these PCs send an unknown unicast at once? What would happen? Multiple copies of the same frame would be sent across, right? So, switch 1 would forward the same packet and it crosses one round. MAC address table of all the switches are updated, but a duplicate copy is received. A duplicate copy is received, but it is received on a different port, right? So again, the MAC address table of all the switches are again updated. So every time a packet is received on a port, the MAC address table is updated. But then the updation happens and there is a fluctuation or the MAC address table duplication. A is received on switch 1 on port 3 and port 2 as well. A here or source MAC of A here is received on port 1 and port 2. So how will the switch decide via which port should it send out the traffic from? It cannot decide. This is a clear example of loop. So the packet is continuously being circulated in the network and it will not be dropped because we do not have a concept of TTL in layer 2. Had there been a concept of TTL in a layer 2 network or a layer 2 header, there will be no looping in a layer 2 network at all. So this is where the spanning tree protocol comes into picture. All right. So when a spanning tree comes into picture in a layer 2 network, what usually happens is that one of the ports in this network gets blocked. Let's say that switch 2's port number 1 is blocked, meaning that this will not forward or receive any traffic. So in our scenario where switch 3 forwards the packet from source A to destination B via its port number 2, it is discarded by the interface 1 of switch 2 and the switch 2 never receives a duplicate packet from switch 3. Similarly, switch 2 will not forward the packet that it received from switch 1 to switch 3 because the port number 1 of switch 2 is blocked, and hence there is no loop. Logically, this particular network would look like this. So there is only one way for switch 3 to talk to switch 2, and it is via switch 1. Similarly, for switch 2, there is only one way to talk to switch 3, and that is via switch 1. Now, in the next video, we will understand how a spanning tree works, what are the different types of spanning tree, what are the fields in the spanning tree, meaning that how are the hello BPDUs in the spanning tree speak to each other, what are the contents inside these BPDUs, and how do they work to manipulate the working of a spanning tree, meaning that how do they decide to block a particular port or an interface in a layer 2 network, which helps in mitigating a loop. Thank you and have a nice day.